All right, so I'm going to talk about here the universal conditional statement. All right, so suppose we are given the predicates P and Q here. So the statement is in this form: for all x, if P of x, then Q of x. That means if P of x true, then Q of x is true. Or the reverse is this right? Okay, so there may appear here some domain here. Okay, some domain for all x in domain D here. D, of course, has to be a common domain. Okay, common domain. So you know that here x has a domain here for the predicate P, and x is a domain for the predicate Q here, but those domains have to coincide. Okay, have to coincide. Otherwise, of course, there is no meaning. Okay, and we're gonna show this thing here in a very more formal thing. Okay, and it is this notation we put here. For all x, P of x implies Q of x. All right, so that's it here. This is the symbols that we use to express this statement here. Of course, you're gonna see again here domain D sometimes. Okay. Otherwise, I mean, it's always, this domain is always understood from the context of the text you're reading. Okay, as a mathematical paper. Okay, it's always understood from the statements. Of course, it's again common domain. Okay, all right, and let me give you another definition, another statement. For all x in the P of x, if and only if Q of x. So the form corresponding to that in symbols you may put like this: for all x in the P of x, if and only if Q of x, right? So that's it here. All right, so this is the end.